Good morning and happy Monday. This week we are going to be working on adding and subtracting fractions. Yes, we continue to review. So yes, this should be very easy for you. All right. So today we're focusing on common denominators and converting between mixed numbers and improper fractions. So first off, why the heck do we have to find a common denominator? You were just reminded that we have to find a common denominator because in order to add or subtract fractions, we have to have the same size pieces. You can't add a mango and an apple. It won't work, all right? You got to have a common ground, a common denominator, same size pieces. So, you know how I like to do this. I like to make a T-chart. So that's what we're going to do. Just like we did with division, we are going to do that to find a common denominator because you know what? Fractions are division. But we knew that. Okay, so all we're going to do is we're going to take these two fractions and find out what the common denominator would be. We're not going to add it. We're not going to subtract them. We are just finding the common denominator. So when I look, I see that the denominators are 12 and 9. So I'm going to make a T-chart for 12 and I'm going to make a T-chart for 9. And as soon as I get a number that is in common, I'm going to stop, and that's going to be what we call our least common denominator, and that's what we want. Okay, so I'm going to make a T-chart for 12 and a T-chart for 9. Now I'm not going to go all the way down yet. I'm just going to start little by little. 1 times 12 is 12. 1 times 9 is 9. 2 times 12 is 24. 2 times 9 is 18. 3 times 12 is 36. 4 times, oops, wow, I just skipped a whole number. 3 times 9 is 27. No numbers in common yet. 4 times 12 is 48. 4 times 9 is 36. Oop! Stop! I see a number in common. 36. And that's it. That's my common denominator. And that's all you're doing today. You're not going to go any further than that. So guess what? This next one, 2 9s and 1 6, you're going to tell me the common denominator in the comments. But don't write the comment yet, because there's one more problem that you're going to solve that's in the next few slides, and you're going to also put that in the comments. So there's two things you're going to have in the comments today. The common denominator for 9 and 6, and then there's another problem a few slides up that you're going to put the answer in the comments. That's that with common denominators. Now we're going to talk about how to change a fraction from a mixed number to an improper fraction. You remember when I used to say, "Ya mad or nah?" And I used to say, use mad, use mad. That's what we're doing. Okay? But before we use mad, let's understand why that works. Okay? So, looking here, 2 2/3 equals 8/3. Why is that true? Well, all we're doing when we use that acronym MAD, when we multiply, add, and the denominator stays the same, all we're really doing is we're looking at that whole number and we're seeing how many fraction pieces that whole number is equal to. So this is what I mean. The fraction 2 2/3, the fraction pieces are thirds. So how many thirds are there in 2 wholes? That's what we're trying to figure out. And then we're adding that to 2/3. So I know that in 1 whole, there's 3/3. So in 2 wholes, there's 6/3. And 2 wholes, or 6/3 plus 2/3, that's equal to 8/3. An easy way to figure out how many fraction pieces are in that whole number is to use that acronym MAD. You just multiply the denominator, or the size of the fraction, or how many pieces are in that fraction, times the whole number, and you add the numerator to it. So in this example, 5 times 3 is 15, plus 2 more is 17. So you have 17/5. The denominator stays the same because we still have those size pieces. I'm going to work 2 of these out for you, and then the third one, the 9 2/10, you are going to write what that improper fraction would be in the comments. So you're going to write the common denominator that I told you to answer in the beginning, and also the answer to number 3 here in the comments. Those 2 things. 7 3/5. Okay, I am going to use MAD. Remember, that stands for multiplication, add, and the denominator stays the same. Okay, so first thing I'm going to do is I am going to multiply the denominator times the whole number, because this is going to tell me how many fifths there are in 7 wholes. So 5 times 7, 35, plus the 3 pieces I already had is 38, and the denominator stays the same. So my fraction that is equivalent to 7 3/5 is 38/5. They equal the same thing. I just took the whole number and converted it into fifths. Next problem. And this one I'm going to write a little bit bigger. 6 5/8. Remember, I'm still following that MAD acronym. Multiply, add, and that denominator stays the same. This is how I change the 6 wholes into eighths, and I add that 5/8 to it. Okay, 8 times 6 is 48, plus 5 more is 53, and the denominator stays the same. So 6 5/8 is equal to 53/8. And that's all, folks. So now you're going to try to convert 9 2/10 into an improper fraction and put it in the comments along with the other problem I asked you to do. Okay, so your exit slip is on Canvas. You're going to be converting these two mixed numbers into improper fractions. And then you have this word problem. All this word problem is asking you to do is to find the common denominator. One of the denominators is 3, the other is 5. What is the common denominator? Answer it on Canvas. In science, we're reviewing the water cycle.
Check it. It goes evaporation, condensation, precipitation, runoff. It goes evaporation, condensation, precipitation, runoff. Or runoff. Evaporation, condensation, precipitation, runoff. It goes evaporation, condensation, precipitation, runoff. Or runoff. Or run off. Or run off. Or run off. It goes evaporation, condensation, precipitation, runoff. It goes evaporation, condensation, precipitation, runoff. A run off, a run out, a run out, a run off.
Alrighty, y'all, you knew that was coming. You knew I couldn't do the water cycle without my jam. Too bad I did not get TikTok famous off of that, but never say never. Okay, so all you're going to do for science today is you're going to watch this video on YouTube. It is on Canvas. It is a video talking about the water cycle, and it is showing you an experiment that we already did this year where we created a model of the water cycle. And this is the model I'm talking about. So this should be pretty familiar to you, where we had 3 cups. The top cup was ice, and in the bottom you had hot water, and then you had a cup upside down taped to it, and you were supposed to observe the water cycle. What you are going to be doing is you are going to be explaining what's happening in the model. You have to use the words condensation, evaporation, and precipitation. Basically, tell me what's going on in each cup. And is it condensation, evaporation, or precipitation? All right. Hint. This ice up here is not, it has nothing to do with, what am I trying to say? This ice is not condensation. A lot of people have a misconception that this ice is supposed to represent condensation. It doesn't. It represents something that causes condensation, but the ice itself is not condensation. Hint, hint. Cough, cough. And then you're going to answer the questions. All of this is on Canvas. If you don't have Canvas, which by now you should, you can answer it on a paper and turn it in to me. Exit slip. also on Canvas. Okay, guys? So, you didn't have Science Friday, but you're making up for it today. You got kind of a lot of work, but it should be easy because I went hard teaching the water cycle, and you know it. So, this should be very easy for you. Have a fabulous Monday. Call me, text me if you need me. This week, I am going to try and make sure that I talk with all of you, each one of you, at least one time. Some of you have been slipping by and you're ignoring my calls. I will find you. Okay, bye. Have a great day.